Welcome everyone to another free GMAT prep hour. My name is Reed Arnold. I'm guiding you through today's lesson. It is November 7th, 2019. Welcome back. If this is your first one, do a little Google search. You'll see several of these posted on YouTube. A lot of really, really good information from our instructors. Various different instructors have done various different topics. We got quant, we got verbal, we got big test stuff. Whether you're just starting out or deep into your studies, we got some things for you to learn. I'm sure you'll find something useful. If you're looking for other free options, you can take our first class for free, whether that is online or in person. That's 1/9 of the entire course. And as I often say, class 1, we go over some really big stuff. Some testing cases, data sufficiency strategies, some big sentence correction strategies, an understanding of how the test works. So it's a free lesson, 11% of a course that you get to take, no questions asked. So you can take advantage of that. You can also try our Interact course. That is our video course. You can get a little sample of that, see if that's something you're interested in. All right. Today's lesson, I didn't make a little title slide, I'm afraid. Today's lesson is, I thought about a lot about what I wanted to do, and I've started to do a drill kind of like the one we're going to do tonight with several different problems in my classes. And it has to do with like what this test is often really testing. And so what I'm going to do is I'm going to start off with what I consider to be like a perfect GMAT question. Okay. So I'm going to have you all take a minute, look at this funny little slide, and see if you can answer it. So we have maybe the baby is me, and yeah, pretend it's me talking. Maybe it's Reed. Is it a picture of Reed as a baby? Maybe. Any other guesses? Good. So Sharon says it's maybe my son or daughter. It's my baby. Maybe it's that. Anything else? Okay. I love this question. I think it is like, for a silly little question, it is the perfect version of what the GMAT often does. The GMAT is a different kind of test, okay? And the concepts, I'm not going to say every concept is simple. There are some pretty tricky concepts that you're going to need to learn or maybe brush up on if it's been a while. But by and large, the concepts are not really the game. It's the deconstruction that you must do to answer the question. You're going to use the concepts, but the concepts themselves are not difficult in the same way that it's not difficult to know what a father is or a sibling is or a baby is. This question is surprisingly complicated for concepts that are really not. Why? Because there's a lot of moving parts. All right. And what you have to do to answer this question is answer it in pieces. You can't just spit out the answer. Even people who are good at this test never spit out the answer. You have to go in pieces. So what we're talking about today is, and this is something you can do when you're studying and reviewing, you just find pieces in the puzzle and make inferences about it. So let's break this into little pieces and let's just say what has to be true based on that little piece. So let's start here. I have no siblings. Just forget everything else for a moment. What does it mean if I have no siblings? And a little, I should say this early. Do not be afraid of saying obvious things. A lot of the questions I ask tonight are obvious, okay? And that's kind of the thing, is that you specify the obvious and it helps you piece together the actual problem. Okay, so no brothers and sisters. I'm an only child, right? I'm the only child of my parents. My parents had one kid. All of those have to, and I am ignoring the possibility of step siblings and adopted children for the purpose of this problem. So my parents only had one kid. Okay. Let's forget something else. Forget what we just did. Now let's just look at another part. My father's son. What is that? Is it me, Abhi? We know I'm a boy, okay? Because I said my father's son. It's me or my brothers, right? That's who my father's son would be, me or my brothers. Okay, that's what that piece means. But, I have no siblings. So let's piece these two simple inferences together. What can we say? Hold up, no, Sonny, don't go. So Sonny says the baby is me. Not yet. Forget the baby. I meant to cover that up for this moment still. Let's just look at, I have no siblings and my father's son. Just combine those information, those pieces of information. What does that mean? Forget the baby. I am my father's only son. My father's son is me. Okay, so we've made a new thing. It's a simple thing, but it's a new thing based on what we have. All right, my father's son is me because I don't have any brothers, because I don't have any siblings. Okay, so let's just get rid of that, and now that we have someone is me, because we've made that inference. Okay, so someone is me. Well, if the someone, as the question originally asked, was this baby's father. So that sentence becomes, this baby's father is me. So this is my baby. Who is this baby? It's my kid. It's not me. My father's son is me, but this baby's father is my father's son. Okay, now this isn't really a picture of my kid. This is a Google stock image of a cute kid making muscle arms, and I don't know, I thought it was cute. I do not have a kid, or I would have displayed them shamelessly. But this right here, this little, yeah, so obviously, like I was thinking more great-grandfather and grandfather, those could have come into play, but you have to work through this chunk of crud. It's simple concepts. It's father, siblings, and sons, right? How can that be hard? Well, when you have to juggle multiple at a time, it overloads the brain. One thing I tell my classes often is that two simple things is hard. That's just how brains work. It is psychological. You are never going to overcome that. You're never going to suddenly do multiple things well. You just do one thing quickly, and you notice what one thing to do. If I work through this thing, I end up with, oh, this is my baby. Who is this baby? It's my kid. You just told me that. That's an easy question, right? The GMAT tells us a really simple thing in really complicated ways, okay? And we have to work through the complication in pieces to get to the simple thing and then answer the question. That deconstruction is the skill that's being tested. Not, do you know what a father is? Do you know what a son is? Of course we do. That's the easy part, okay? This question also has a nice little gut response. A lot of people say, oh, the baby's you, because my father's son so often means me. We're kind of used to that little game, but we've actually built a more complicated relationship here. So not actually a question that's going to be on the test, but like a perfect representation of one, okay? So today's lesson is about, this is Patrick Tyrell, one of the instructors at Manhattan Prep, and I've badly photoshopped his upper torso onto a fortune teller. And I've put a little GMAT question up here because I think there's like this general sense. Laura, I see your question. I'll go back and explain. There's a general sense that people who are good at this test just like take in a question and then just like spit out an answer, right? We just have like a crystal ball. We look into the pensieve, if you're a Harry Potter fan, we see the question and it's like, oh, there's the answer. We just kind of spit it out. And that's not how it works. Even people who do these questions really fast do them in very little discrete steps. And so today is all about practicing and finding those discrete steps. So one quick little wrap up on why this picture is not me, but is my kid, because my father's son is me. Right? My father's son is me. Why is it me? Because I have no siblings. So we take off these little pieces of information and we're left with this baby's father is me. Well, if this baby's father is me, that means this is my baby, which means who is this baby? My kid. Okay. So it's just a deconstruction that gets to the answer of the question. We don't just spit it out. We have to work for it. We have to make our brain dig through and sift through stuff. It's not a game you can just answer. It's not trivia, right? How tall is Shaquille O'Neal? What is the largest organelle in a plant cell? Who fought at the Battle of Hastings? That's trivia. Your brain either instantly knows it or instantly doesn't. And it just spits out an answer, or it says, I don't know that. And you can't answer it unless you go and research. Okay. Nobody answers the GMAT like trivia. It's always done in little pieces. Okay. So all we're doing today is we're going to work on finding portions of a problem and just realizing what that portion tells us, what inference we can make from little portions. Okay. What we're going to do today, I want to be clear, is not the way you will actually work through problems on the test. Okay. Although I do think it is a good habit if you find yourself stuck on the test to just find one moment in the problem, just find one thing that you can deal with. That is a good habit. But we're going to go through things a little bit out of order. I'm going to be blotting out a lot of the questions at once. Okay. And that's something I want you to do when you're reviewing. When you find yourself stuck on a problem and you need to review it, put the clock away, and then just say like, okay, let's pretend I knew nothing about this problem except the one piece mentioned in this sentence. What does that one piece tell me? And don't worry about answering anything. Today, we are not worrying about answering questions. We are worrying about taking a little nugget and drawing inferences. Okay? So when I say gym work, I mean that's something you do at the gym. Football players lift weight at the gym so that they can play a game. But when they're, need to jump for a ball, they don't think about all the squats they've done before. They just jump for the ball. That's what we call gym work. It makes you better, but it's not actually the process for the game day when you're in the test. There's another video that I realized we've done before that is somewhat similar to this. It's Jeff Vollmer's Hidden Clues in Quant Problems on April 23rd, I think it was. It's not going to be quite structured the same way, but it's a similar idea, which is find the moments in the question that give you insight. We will not just do quant today, though. I will show you how this game is also done in verbal in certain situations. Okay. So with that, let's get started. I've blotted out most of the problem here. We're going to start with a simpler example. If 31 is less than y is less than 36, what can you tell me about y? And again, don't be worried about being obvious or silly or weird. Just tell me true things you know about y. (31.1 to 35.9). Is that true? It could be 35.999. Yeah, right. It could be anything really, really close. It's infinitely close to those endpoints. Okay. Good. So 31 and a very small decimal up to 35 and a really big decimal. Or it could be the integers in between. We don't know. We're not told. Good. I'm glad no one thought, oh, the lowest it can be is 32, because we're not told that y is an integer, not from this piece alone. So what else can you tell me about y? If y is 31 to 36, is there any other inferences? And I'm going to ask this a lot just to, You know, when you think you've got, okay, good. So Sunny says that y is positive, right? That's not actually, you know, said anywhere. It's just that if y is between 31 and 36, it has to be positive. Maybe that's going to be a useful inference in the problem. I don't know. Maybe not. It would depend on the situation. But I know it's true. Very good, Sunny. That's the kind of thing I'm looking for. Okay. You know y is not 100. It's not 10 million. Okay. Good. Now let's go here. Different statement. Y is an odd integer. What inference can you make from that? It could be 1 or 3 or 5 or 7. It's not divisible by 2. It's not even or 0. 0 PS 0 is technically an even integer, just so you know. Okay. It doesn't actually have to be positive. You can have odd negatives, although the GMAT doesn't usually deal with that. You technically can have odd negatives. Okay, good. So now let's combine some information. Now we have both of these statements together. What inference do we make? Good. Good. So now we know y is either 33 or 35. That's what these two facts give us, okay? Very good. Now let's bring in something a little different. And again, try to start over with every inference just because that's the drill today. If I told you y is between 28 and 34, and y 31 is less than y is less than 36, what inference could you make from that? Good. Yeah. Now I have the 31.000000001 to 33.999999. Really what this tells me is that 31 is less than y is less than 34. I actually have a new endpoint. This is actually too big, and this is too low. Very good. Okay. Now we bring in everything. Yeah, these two pieces of information, if we synthesize all the inferences we've made, these two pieces tell me y is 33. Okay. That's the only odd integer between 31 and 34. Okay. So this answer, if this were, this is a data sufficiency question, the answer would be C. Okay. P.S. What makes sense? What I said in the beginning. Oh yeah, deconstruct. Yes, right. Okay, this is you deconstruct a problem. Now this question is on the easier side. All the questions we see tonight, by the way, are from the official practice tests. Okay, so these are real GMAT questions. And this is an admittedly easier example, but I want to show that even on the harder examples, this basic thinking style is what we do. It's a little bit easier to see how to think in this situation. The inferences are a little bit more obvious, but it's that skill of making inferences that is going to be the constant. Okay, and so if I just worry that people sometimes focus so much on I need to learn the content, and yes, I mean you do. But you really need to learn how to make inferences, how to pick a piece and see what it tells you. Okay, so that's what we're doing tonight. So, new situation. Again, I'm blotting out certain parts of the problem. 206-ounce servings of orange juice. Good. I have 1,200 ounces. That's what that means. Okay. 1,200 ounces of OJ, orange juice. Okay. Let's put that aside. I brought in the answers here. Sonny, forget the 200 cans first, or forget the 1,200 ounces for a second. I just want you to deal with the inferences on the screen. How many 12-ounce cans of concentrate are required? And then I have these answers. So Laura says, how much OJ do you have? Is that a question, Laura? We need to know what the amount of mixture is missing here. Okay, Laura says that's an inference. How can I infer how much OJ I have? How do I combine the information on the screen? Good, Sharon. Sharon's got it. Okay, look, this is the question. This is clearly going to be the question. How many 12-ounce cans of concentration are required? Concentrate. And I have these answers. And so I know that there are 5 possible situations. I either have 12 times 25, that's 300 ounces, or 12 times 34, which I don't know off the top of my head, I'd have to do the math. 12 times 50, that's gonna be 600. 12 times 67, that's gonna be a big number, 720, 700 something. Maybe almost 800, or it could be 1,200. 12 times 67. I can infer about this situation that I have either 300 ounces of concentrate, 12 times 34 ounces of concentrate, which would be 360 plus 48, it'd be 408. I should just do the math. I either have 300 ounces of concentrate, 408 ounces of concentrate, 600 ounces of concentrate, 12 times 60 is 720, 12 times 7 is 84, so 804, I think. Or 1,200, that math might be wrong, I'm doing it in my head. Okay, so I know it's like, do you really know anything? Well, I know something. Yeah, I know that I have 5 possibilities here. I have either 300, 408, 600, 804, or 1,200 ounces of concentrate. Okay, this is what you do if you ever back solve, if you ever plug in the answers. But you need to realize, oh, I can make that inference. If I have a question and I have these answers, they give me certain possibilities. Okay, now who here, we talked about 1,200 earlier, so you might be like, oh, 1,200, I'm done. I've answered the question, even though Reed hasn't showed me the whole question yet. I kind of doubt it. I've covered up a lot. Okay, the GMAT's going to punish you for making inferences on incomplete information, and we actually have something, a different little wrinkle to this problem. For one, these are ounces of what? 300 ounces, 408 ounces, 600 ounces. What are these ounces of? They're not ounces of the can. The cans are 12. They're ounces of concentrate. And what was the 1,200 ounces of? 1,200 was the ounces of OJ. Okay, and that's different than the concentrate. And so I'm actually quite certain it's not 100, because I think there's going to be more information to come, and there is. Okay. So let's forget everything else for a second. Again, we're not really trying to answer questions. What can you tell me if 1 can of concentrate is to be mixed with 3 cans of water to make orange juice? What is this? What does this little piece of the puzzle tell me? It's a ratio. Good. It tells me that the juice, I have a concentration and water concentration, and it's 1 to 3. Okay. Now I do want to be clear here. Some people are bringing OJ into this equation. The OJ is something else. What would the OJ be in this ratio? 4. Yeah, don't mix up the OJ and the concentrate. Don't mix up the part for the entirety. The concentration and the water become the OJ. Okay, so the orange juice is 1 part concentrate, 3 part water. That's just an inference I know from this information. I don't, again, this can come anywhere. It can come anywhere. It can come in a word problem. It can come in a problem-solving question. It can be on the back of the instructions of my orange juice in the morning. All we're trying to do is just think and draw inferences. We're not actually trying to do well on the GMAT right now. What happens if I bring the 12-ounce cans of concentrate into this situation? Now we start combining information. We start combining inferences. Good, Avi. If it's a 1 to 3 concentrate to water, then it's 12 to 36 ounces. 1 can is 12 ounces. That means 36 ounces of water. Very good. Okay. Go to there. Yeah, there we go. How about here? Let's bring back the 1,200 ounces that we had at the beginning, the first inference we made. So I have a 1 to 3 ratio. The concentrate to water ratio is still 1 to 3. And now I have the 1,200 ounces of juice. So what inference can I make? Laura says 300 is the change factor. We call that the unknown multiplier in our literature if you have our books. But yeah, it's if the ratio is 1 to 3 to 4, and there's actually 1,200 ounces of OJ, then we multiply by 300. So we actually have 300 to 900 to 1,200. That's what I know from these pieces of information. This gives me, the first one gave me the ratio. Then I'm asked about 206 ounce servings. That's 1,200 ounces. Okay, well, if it's a 1 to 3 to 4 ratio and there's 1,200 ounces, it's a 300 to 900. Those are the component parts. Okay. And then we answer the question. So see if you can tie it all together. Yep. I have 300 ounces of concentrate. And the last inference we have to make is, okay, if there's 300 ounces of concentrate and they're 12-ounce cans, that's going to give me 25 cans. Okay. Now, I said the point was not to do problems and it's not to get questions right, and it's not. But, I mean, what we're doing is how you get questions right. When, you know, and this is kind of the thesis, is that you answer these questions by working in tiny little steps and deconstructing the situation, not by just knowing, not by just, oh, good, done. You pick pieces. And if you ever find yourself, like it's almost, you just don't try to answer the question, try to figure out what you know based on what they tell you. And it turns out that what you figure out is going to be what the answer is. Okay, if you deconstruct the situation well, the right answer usually pops up. All right, let's try another one here. This is going to be a data sufficiency question. Yeah, so Avi says my reflex is always, I'm gonna stop because I think that's such a good point. Avi says my reflex is always to start forming equations in his head. And sometimes algebraic equations are a useful tool, and sometimes you can make algebraic equations. You could have done that on the problem we just did. I'm sure there's some algebraic equation you can make, but it's way overused, and a lot of really good test takers don't really rely on it as much as you probably think they do. Algebra is one tool of several that you have. And even when you're doing algebra, though, it involves this breaking down first and building the thing in pieces. Algebra, I actually just learned this today. Oh, I don't want to mess this up. Algebra means, in fact, I'm going to look it up. Sorry, because I just thought this was so cool. And it's very relevant to the discussion. And I meant to include it. Let me see if I can do this quickly without being too annoying. Literally means, algebra means the reunion of broken parts. Ha. That's what algebra means, because math, you break it apart and then you bring it back together. And that's what we're doing right now. We're breaking apart the situation. We're recombining it in a way that's useful to us to answer this question. Okay. So even when you're doing algebra, you break it apart, you build the pieces, and then you work out. And it's usually that part that needs the most practice. And sometimes you don't even need to actually build the equations. Okay, so let's go back to this question here. What can you tell me? What inference can you make so far? Good. It's a sequence of 15 terms. That's kind of all we know. Laura, we actually don't know there's a common difference. Not yet. All you know is there's a sequence of 15 terms. I don't tell you how the sequence is generated. We'll find out. Okay. Now what inference do you know? We know the relationship between each term, do we? We know the relationship? Okay. So there's some relation between the terms. We don't know exactly what it is. It's an arithmetic progression if you know the math terms. We know there's a common difference between terms. Okay. We take the term before, we add k to it, we get the next term. Yeah, the current term is the previous term plus a constant. Do we know, so do we know anything about that constant? What could that constant be? Could be positive or negative. Good. Okay. So if if k is positive, what does that mean about the next term? Like, I'm going to really push, like, make as many inferences as you can. And I'm going to call this kind of the hypothetical inferences. This is an important skill, to consider the different hypothetical situations and make an inference from there. What do you know? What's going on here? Besides the fact that this has gone weird. There we go. What do we know if K is positive? What is greater than the last term? I think you're right, son. I just want to be clear. Oh, good, Laura. That's a new inference we hadn't actually talked about here. That's very good. Laura is actually also noting that the median is going to be the 7th term. That's a good thought. And the average is going to, we have a set of consecutive integers. So the average is going to be the first plus the last over 2. Those are all true things. Median equals the 7th term, since these are in order. The average is going to be the highest plus the lowest over 2. Good. And we know that if K is positive, the current term is greater than the previous. Very good. And if K is negative, the opposite. Yeah, if K is negative, then the previous term is actually higher than the current term. Very good. Okay. I don't know why it keeps doing that. Stop. Okay. So let's take what we have so far and let's look at statement 2. Again, this is not how you do this on the test. I'm just doing an exercise here. Let's say, okay, A8 is 10. Hold up. I want to go back to the median. The median is not the 7th term. The median is going to be the 8th term. Yeah. Okay, so this tells us the median. Okay, tells us the median is 10. What else can you tell me then? Keep making inferences from there, even if they're simple ones. So Laura says there's 7 terms below 10 and there's 7 terms above 10. Okay. Georgius, I don't know if A7 is less than 10 because I don't know if K is positive or negative. Yeah, Sharon, good. I don't know if K is positive or negative, so I don't know if I'm moving down and I pass 10 at A7 or if I'm moving up and I pass 10 at A7. It's hard to say. But I do know 10 is the median, and I know that there are then 7 terms below 10. I don't know if it's the 7 before or the 7 after, but I know there are 7 terms below 10 and 7 terms above 10. Okay. I think I skipped a slide by accident. That's okay. Kind of spoiling the broth. I didn't mean to put this in this order, I think. Oh well. Pretend we didn't just have that discussion. What inferences would you make if this was the question you saw? You know there's a sequence, 15 terms in it. We know that we're adding a constant every time. We don't know if it's positive or negative. Okay, we need to know where we hit 10. Okay, we need to know if 10 is one of the numbers, or if we cross 10 at some point. It is hard to make any clear inferences, but you can just consider the possible worlds, I guess. And then when you bring it all together, well, as we just saw with statement 2, when we know that the 8th term is 10, that means that there are 7 above and 7 below. Even if, notice in this situation, we don't know what k is. We don't know if it's positive. We don't know if it's negative. But we know that when the median is 10, when that 8th term is 10, 7 terms are below and 7 terms are above. We already made that realization without actually seeing what question was asked. Okay. Take the situation, take a little piece, and just build it out. See what you know. Good. I was hoping we would do a verbal one as well. We'll do a verbal. We might do another, if we have time, we might do another quant, but I also want to do a reading comp. So this is a sentence correction. And all I've given you is this part of the sentence. That's it. And that this robe depicted. And I'm asking you to make an inference about this sentence. What inference can you make based on these 5 words of this sentence? You don't even know what it is. Good, Abby. It's a parallelism trigger. If you all were here for the last free GMAT prep hour, I did a whole session on parallelism. I actually used this very question, but I think it's a good one. So it's a parallelism trigger. Okay, so what does that make me think about the rest of the sentence? What must be in the previous part of the sentence? Yeah. Somewhere earlier in the sentence, there must be another that. Something that and that. I don't know anything else about this sentence technically right now, but I know somewhere the word that has got to appear. That's an inference based on a little piece of information in this sentence. Okay, I notice that piece, I make an inference. How about this? What if you see from ancient Athens? What can you infer? Okay, James says it's a modifier. It's a prepositional phrase. So what can I infer is going to be in this sentence? Something that's from ancient Athens, right? I know it's obvious, but you specify that, and then you see, when you see modifiers, you check the thing that's modified. Make sure it makes sense to be from ancient Athens. Okay. Now I included this in this sentence. This from the sentence just to show you an example where when you do this drill, like this particular split isn't all that important in this particular question, but for other questions, it's hugely important, and you have to build the stimulus response. Okay, something's from somewhere, check the modified, check what it modifies. That's the point of the drill. We're not really trying to do questions, we're just trying to draw inferences. What if you see had collaborated somewhere in a sentence? It's more than the past. Good, James, I like that. It's a verb signpost. What does this mean if you see had collaborated? You have to see another verb in the past tense. Probably. I guess there's 2 things you need to see. You either need to see a verb in the past tense, because this is called the past perfect. Again, this is you do have to know the concepts, right? There's no getting around it. If this is your first introduction to past perfect, you can tuck it away and study it and learn it. But basically, the past perfect is something that had to happen before another event in the past. And so I need something else in the past for the collaboration to happen before. So I either need a verb in the past or a phrase like before sunrise, they had collaborated to assassinate Caesar. I don't know. Some past event for the collaboration to happen before. I just know that. And if I don't have it, it's wrong, right? That's the beauty of just noticing this little piece gives me an inference. And I have to find the other component. And if it's not there, it's wrong. Okay. So that's the whole sentence. Again, that's not the point of today. You can check the parallelism video for that. All right. But you can use the inferences here to narrow down to answers. When you see and that, you have to have a that somewhere. And so you find the answers and you see the ones that have that. No. Collaborate to weave, no. I think there are two. Oh no, there's one here. See, this is what got me almost last time. Yeah, there's the that. Okay. So you have a few that have a that, you just have to look for it. Okay. You can use the past tense as well. Oh, do I want to do the carrots? Let me see. Got 10 minutes left. What other math problems were there? Let me take a look. I'm gonna go off screen for just a moment just to see which problems I want to do in the last 10 minutes. So these things always go so much faster than you think they will. Where are all these slides? Okay. Yeah, that one's kind of dull. Oh, yeah, let's do this one. Because we already did the rabbit one. The reason I'm not sure I want to do the rabbit one is because it's actually not all that different from the orange juice one we saw earlier. It's kind of a similar game. It's not rates, but it's weighted averages and percentages. It's similar enough. So let's do a different question here. If n is a positive integer, and then I have n minus 1 times n plus 1. So if n equals 1 or negative 1, then this is going to equal 0. Well, I guess it can't be. N can't be negative 1. Why can't n be negative 1? Because it says positive. But if n is 1, then this thing is going to equal 0. Okay. James says both terms either positive or negative. No, I think these terms are going to be either 0 or positive, because n is a positive integer. I could turn this into, good. One inference you might make here is that this is n squared minus 1. That's a commonly tested quadratic. What else can you tell me about n minus 1 times n plus 1? Laura says multiplication is even. Is she right? N can be, well, n can't be 0, but n minus 1 could be 0. Depends on the terms. What does it depend on? What's going to go on in this even, odd world? What's going to happen? Make an inference about it. Consider the hypotheticals. So yeah, Sonny, good. Those are the even and odd multiplication rules. What do you know about n minus 1 and n plus 1? we're going to be thinking about even and odd here, but let's make the correct inference. If I have a number -1 times a number +1, good. So Melanie says, hey, here's an inference. They're 2 units away from each other. What does that mean? So I have two consecutive integers is what this means. Good, Melanie. So they're either both even or both odd. And yes, n is the number in between. Okay. So these terms are either both even or they're both odd. Okay. We'll keep digging into this here in a second. Let's go to statement 2 and draw an inference here. N is not divisible by 3. When I have this product, n minus 1 and n times n plus 1. Good, Ollie. So you're talking about the evens and odds. That's true. Why can't n be 2 or 4? I think n could be 2 or 4. Well, Melanie, that's true. One of these numbers would be divisible by 3, but what am I told? What number is not divisible by 3? Draw it out. Here we haven't quite hit this inference yet. If I have n minus 1 and n plus 1, we'll come back to the even and odd discussion. They're either both even or both odd. Okay. But here we're talking about divisible by 3, which is a little bit different than even and odd. If n is not divisible by 3, what can you tell me about n minus 1 times n plus 1? Good, Sharon. Sharon says either the product is 0 or it's divisible by 3. And just to be clear, 0 is divisible by 3. 0 is a multiple of everything. Okay. Well, James, I don't know if n minus 1 or n plus 1 are even yet. I don't know that. But I do know that if n is not divisible by 3, this is not divisible by 3. So it's not 3 or 6 or 9 or 12. What does that mean about one of these numbers? Okay, that's true. The product of 3 consecutive integers does have to be divisible by 3. That's a rule generated from this inference. And I just want to point out that even if you didn't know that rule, you can still learn on the fly if you make the correct inference. If n is not divisible by 3, well, one of these neighbors has to be. Either I have, 3, 4, 5, or I have 4, 5, 6. No cat. Or I have, 10, 11, 12. Somewhere I have a multiple of 3, it just can't be n. So this tells me that this product is a multiple of 3. That's the inference we make here. Okay, we know that this is a multiple of 3. Is that clear? Do we see how that works, or is that confusing? Okay. If it doesn't, there's actually a video I did called What is Divisibility Anyway? Although I don't know if it has the title on YouTube, it might be a date. But I cover a similar topic like this. I call this the remainder cycle. It's a game the GMAT plays with divisibility. Okay, what if n is not divisible by 2? What does that mean? That means n is odd, okay? What does that mean? Keep making inferences where you can. Anytime you can make an inference, make an inference. That's what this drill is. So we know n is odd. Good, that means n minus 1 and n plus 1 are both even. So I have an even times an even, okay? What do you know about an even number times an even number? It's even, that's true. What else do you know about an even number times an even number? It's divisible by 2? Yeah, that's what even is. Do you know if it's divisible by anything else? Now, Laura, it could be divisible by 3. I don't know, I could have, 12 times 4. 12, that's going to be 36. That could be divisible by 3. Good, Sharon, it will be divisible by 4. Because I have a 2 here and a 2 here in the factorization. When I multiply that together, I have a 4. This number is double even. It's divisible by even twice, guaranteed. Okay. What about when we have consecutive even numbers, though? This is even more specific. Yeah, it's going to be divisible by 8. That's what this means, because I'm going to have a number that's even. That means it's going to be divisible by 2. But whenever I have consecutive even numbers, if you'll look, every other even number is a multiple of 4. 10, 12. Okay, so every other even number is a multiple of 4. So one of these numbers, since they're both even, one of them is a multiple of 4. So I multiply a multiple of 4 times a multiple of 2. I actually get that this is a multiple of 8. I know that. And then when I combine the information, when I bring it all together, okay, I know that it's a multiple of 8, and I know that it's a multiple of 3, the product. When I say it, I want to be clear here. It, I don't mean n, I mean the product here. Statement 1 tells me product is a multiple of 8. Statement 2 tells me product is a multiple of 3. But what can you tell me about products that are multiples of 8 and 3? Product is a multiple of 24. So now to the actual question, what is the remainder when we divide by 24? 0. We have an answer. Okay. Laura, actually, no, it is. It's a multiple of 8 because these are consecutive even numbers. If I just have a generic even times a generic even, I only know it's a multiple of 4. It could be a multiple of 8, I just don't know. But if it's a consecutive even numbers, like these are, one of them is a multiple of 4, one of them is a multiple of 8. Okay. Just take a list of even numbers, 12, 10, 12, 14, 16, 18. If you multiply any two of these together, you're going to get, I should have picked easier numbers, 4, 6, 8, 10, 12. If you multiply any of those together, you're going to get a multiple of 4, 24, 48, 80, 120, all multiples of 4, all multiples of 8, excuse me. Okay, so it's these little, you have to specify what this is, consecutive numbers. They're either both even or both odd. If they're both even, then I have a multiple of 8 at the end of this product. If they're both odd, I don't really know much. Okay. Then statement 1 tells me they're both even. Oh, that's convenient. Now I know it's the product is divisible by 8. Statement 2 tells me n is not divisible by 3, which means one of these is divisible by 3, which means ultimately I end up at a multiple of 24. Okay. So this drill that we're doing today, I didn't get to do the reading comp. That's the one last thing I wanted to do, but I'm afraid we're a little short on time here. I'm just going to show you kind of what you can do. Just take a passage like this and just read through and stop when you think, you know, okay, I can make an inference. Okay. Here it would be probably about, right, it's this first paragraph, or first chunks, it's all one paragraph. This is the moment where I was like, okay, I can make an inference here. See if you all can find an inference in this first paragraph. Yeah, so there are different definitions of pheromones. That's, I mean, I know it's like, it's kind of like a summary, but that's the point, right? There's multiple ideas of what a pheromone is. Okay, there's no agreement. Classifying pheromones, in what regard? What is the classification question here? Good, there's 2 groups without a consensus. There's something most people believe. Oh yeah, so we have the thing, we agree on this. We agree that pheromones elicit a specific behavioral response. Okay. I don't know if it's a minority, Laura. It's hard for me to say if some is a minority or not. I just know that some people say that there's more than that. It's not just that it elicits a response, it's that it also has to be unconscious. And so the inference I kind of make is that there's two ideas of what pheromones are. Some say pheromones elicit a response, either conscious or unconscious. And some say pheromones elicit only an unconscious response, which means to me that there are some things that are consciously detected that elicit a response. We have things that elicit response with a conscious detection, and things that elicit response with an unconscious detection. And it's a question of whether those are both pheromones or not. I didn't draw that chart very well, but and you read for the purpose of finding parts of the passage that, hey, I have a new piece of information here. that I can synthesize from what's been given. And then many questions on the GMAT, of course, are inference questions. Again, this is not how you read on the test. Definitely not. This is a gym work. This is just something you can do to practice your sense of where an inference comes, because that's a big part of the test, is where are there these little like I've had these slides where we have little tiny pieces. So for instance, this piece right here, not all chemical signals transmitted via the VNO qualify as pheromones. That just tells me that the VNO has chemical that there are non-pheromones transmitted by the VNO. That's just an inference I know now. Okay. And so you look for these little nuggets where you can have a thought that must be true based on what's written. It can be in the quant or the verbal. It can be in critical reasoning. It can be in sentence correction, but you practice finding the parts of the question that that you can synthesize into a new piece of information. And it's all about that deconstruction from there. It's not about just having an answer. It's not so easy. Okay. Go to the end of the slides here. Didn't get to all of them, I apologize, but I did get the basic points across, I think. Upcoming courses, you can check manhattanprep.com/GMAT/classes. Again, you can try our first course for free. We have these free GMAT prep hours every 2 weeks or so. All right, so hope to see some of you all at the next one. I will stick around now to answer any questions our present members have, present audience. If you're watching on YouTube, best of luck in your studies. Hope to see you around the campus. All right, have a good night. Best of luck. Happy studying.